Okay, before we get totally silly, let's go ahead and figure out how long it's going to take this investment to grow to $10 million, right? Now, $100 at 4% was going to take 350 years or something like that, right? So that's grandchildren's grandchildren's grandchildren, right? Yeah.
But what if your principal is increasing every year also? So say like you growing the interest in it because you throwing money in there.
Yeah, well, that's an annuity, and we can talk about that, but not until we understand this, okay? That's a really good question, and that's exactly why you kind of need to understand this, okay? Because, basically, I've been contributing to the annuities for the last 20 years or so, a certain amount of my paycheck, and as soon as the stock market crashes, I'll regret that, okay? But I don't really think it's going to crash. Hope it doesn't. If it doesn't, I'll eat more beans. Okay, cheap. Good nutrition. People don't want to be around you, but okay. Anyhow, so we set $1,000 times. People don't want to be around me anyway.
What? You know.
Equals 10 million, so it doesn't make any difference. My diet's irrelevant. Okay. I said stop having so much fun. Okay. So we solve this. It's really easy to solve. What do? There's an equation. How do we solve it? Divide by $1,000, and you get 1.06 to the T equals 10,000.
So that's it.
And now what do? Well, we convert this to exponential form.
Yep.
Okay? So, using our rule, which I don't have up here, but this is B to the A equals C, right?
Mm-hmm.
So T equals what?
A. It's A, right?
Okay, so it's helpful to write down the rule anytime you need it, right?
Yes.
Yeah.
2 to the B.
It should be B equals A.
Log base
Said
B
wrong.
of C equals A, right?
So 1.06 is
So T is your A, right? So this is log to the base 1.06 of 10,000. How do you calculate that?
with a calculator.
Well, what rule do
Log.
you use?
Log of 10,000
That's the
over
log of
Right, I want
10,000
over log of 1.06.
divided by the log of 1.06. Well, the LOG log of 10,000 is 4. The LOG log of 1.06 is maybe 0.1, or I don't know.
Log of 1.06 is 0.025.
Yeah, okay.
Yeah, okay.
So what do you get when you divide it out?
158.
158 years. That's less than half the time it took our $100 investment to get to 10 million, right? At 4%. So going from 4% to 6% cuts the time about in half. Okay? Okay, now there's a rule of thumb called the Rule 72, but I'm not going to tell you about that
Oh,
yet.
goodness.
Because that's just something it works pretty well. Okay? Tells you approximately how long it takes your money to double. Okay? And then you have to figure out how many doubling times you have here. Well, that's a different subject, and we get into it. But do we understand how this sort of calculation can be relevant? If you have more realistic goals, how long is it going to take you to get from 1,000 to 10,000? Okay? Still going to take a while, 40 years or so.
That's
Okay.
less than a lot.
But,
That's
you know,
just
40
leaving
years
it.
ago I was working here, you know, 400 years ago I think I was working here. So if I'd invested 1,000 then, it'd be worth 10,000 now.
Dang.
Okay? Of course,
Should've
$1,000
invested
then
Yeah, true.
was more
Good point.
money, more buying power than $1,000 now, right? Probably not more than 10,000, so I'd have probably come out ahead. Okay? If I had bought that rototiller. Okay? Okay, so you understand that this stuff can be really relevant. This also applies to population dynamics. Okay? You throw a couple of guppies into a bowl of water, and pretty soon you've got a dense chunk of guppy instead of an aquarium. Okay? I mean, you got a lot of guppies. Okay? You can't see through the aquarium if you keep feeding them. Okay, well, what happens?
Another chunk of keto.
The reason for that is the little suckers reproduce. Okay, so let's say every month, each guppy produces 10 guppies.
That's a bunch of
Well,
guppies.
like,
Okay? So you start with 2 guppies, then you got 20, then you got 200, and then you got 2,000 in 3 months.
that's all I got.
That's a lot of
That's
guppies.
a lot of guppies.
Now that's assuming they
It's a
have
chunk
enough
of
space and there's enough food. That's unrestricted population growth. It's exponential. It's just 2 to the number of, or 10 to the power times the number you started with, right? So population dynamics, a lot of other applications that we're going to end up talking about, okay? It's good stuff, it's important stuff. And then we talk about what happens to your guppies if they start running out of space. Well, they start going up exponentially, just like a 2 to the T function. But that tank's only going to hold so many, so it goes up like this, but then it starts leveling out, giving you this S-shaped curve, okay? Backwards S, okay?